In this video, we're going to go over 4 different examples. Here's the very first one, and part of this is just learning how to correctly type in each function. So with me, please, after you've cleared the RAM, go up to y equals, and we're going to start by a beginning parentheses and 3 subtract x, and parentheses and squaring it. And we're going to divide this entire numerator by 2. Now, when I look at this function in standard form, which means I hit zoom and I go down to number 6, notice that standard form will always go from -10 to +10 for the x's and -10 to +10 for the y's. Always, that is the standard window. Let's now calculate what is the y value that is associated with 8. A couple different ways we can do that. You take your own preference. Personally, I do not like going second table and then looking because oftentimes I would have to move this up or down. I prefer second, calculate, value, and I type in 8. So 8 is associated with 12.5. Now when I type in 18, there's going to be a problem. Please watch. Second, calculate value, I type in 18 and it's going to say error. Why does it say error? Because in standard form, when we're looking at this window, I'm only going out to +10. Notice the maximum for x right now is set at 10, but I want to go out to 18. So I need to set that, and it has to be a minimum of 18. It could be anything past 18. Now I can try it, and I can attempt to find the corresponding y value for 18 by going second, calculate value, type in 18, and we can see it is equivalent to 112.5. When I look at this function, I see an absolute minimum. That means it's one point that stands out as the lowest point. And today, I'm going to show you 2 different ways to find that. There's going to be what I call the slow way and the fast way, but you get to choose whatever way makes the most sense to you. We're all going to start by doing the slow way, which I demonstrated yesterday. So to find the coordinates of the absolute minimum, can everybody go second, calculate, and go down to minimum? This is the slow way. I will show you both ways, but ultimately you get to decide which method works best for you. The slow way starts by me starting to take this and place it at the lowest point, and then I follow the directions. The directions say go left to the lowest point. How far to the left? That's up to you. I press enter, which is located in the bottom right-hand corner of your keyboard. I go back to the lowest point and I follow the directions. I go to the right and I press enter. And then I press enter one more time, and we can see that the absolute minimum for this function occurs at 3, and now I need everybody to listen to this. In scientific notation, if we took this decimal and we moved it 12 places to the left, this would be approximately 0. So what would be the minimum for this function? Oh, I'm so sorry, it's getting wonky there. What is the minimum for this function? It's approximately 3, 0. 3, 0. The next thing we want to do for this example is the table of values. The table of values, how do we correctly plug this in? So we are going to start by going second table set. Second table set. The very first number I'm going to type in is 100. And then this is going to be the change in the table. So when I look at the input values, notice they go up by 25 each time. They go up by 25. So I'm going to increase by 25. Now to actually look at the table, notice that table is in blue. So I hit second table, and we can see what 100 corresponds to, what 125 corresponds to, and what 150 corresponds to. How do we identify the y-intercept? Well, the y-intercept will always have an x value of 0. So I can do second, calculate, value, and type in 0. We can see 0 corresponds with 4.5. I start the second example. Let's clear the RAM. Second plus 712. Let's clear the RAM. At this time, we have an exponential function. So let's go up to y equals. And how might some students struggle to plug this in? Well, they recognize that 3 is the base and that x is in the exponent position. So to raise it, I'm going to find the caret key, which is on the right-hand side above the division sign. And now I need to bring it back down to the same level as the base, or the 3. You're going to use the arrow on the right to bring it back down and subtract 1. Let's graph this in standard window. Just so I can see where you are, can you do a quick hand raise for me if you are at this point? Great. How do I find out the corresponding value for 2? Two different ways. You could do second table, okay, 2 corresponds to 8, or you could go second, calculate value, and we can see 2 corresponds to 8. That is up to you. How do I complete this table? Well, let's set the table function. So go second, table set. The very first number for my inputs is 15, so we're going to type in 15. And then from one value to the next, I can see I'm increasing by 5. I'm going up by 5. So I'm going to put 5 into the change of table inputs. Now when I hit second table, we can see what each value corresponds to. And as a reminder, when you do see E, this is really approximately 0, right? It's getting closer and closer, we can see here, to the x-axis. So as students begin to plug this in, as a quick reminder, whenever we have a fraction, we're going to put a parenthesis around that value. So parenthesis 1/2 x raised to the 4th. Now don't forget, we have to bring this back down using the arrow. Plus, we have another fraction, 3 divided by 4, x to the 3rd. Bring it back down. This is subtraction, not negative. Subtract 10x squared plus x minus 4. 3 things here. 1 is, can you plug it in correctly? 2 is, can we adjust the window so we actually see the function? And then we're going to analyze it. So please do me a favor and let's go zoom standard. I see a good portion of this function, but I really don't see the entire thing. If this was a curtain, and the y values, you could raise the curtain up or lower it, we can see that I would have to lower the curtain or lower the y values in order to see the very bottom of this function. So let's go to Windows. Let's find the y minimum, and it only goes down to -10. At this point, it really is just like a guess and check. Let's try -25. So type in -25 for only the y minimum and hit graph. Still not low enough. Let's go back up to Windows. Let's try, I don't know, -60. It's getting closer. Still not low enough. Let's try -100. And at -100, I finally can see the graph that I need to. The last part of this example, I want to identify the absolute max and the absolute minimum first. In this graph, there is no absolute maximum. Turn to your partner. Why does no absolute maximum exist? Go. I like this. I heard Jonathan say the graph is continuously going up. I can promise you this is a question on your AP exam. The one in May, they're going to give you a problem like this, and they're going to say, what is the absolute maximum? And you would, the words we will learn would be that as we go to the right, it goes up without bounds. It means there's no limit how high it goes, and there's no limit how high it goes as it moves to the left. So there is no absolute maximum. But here's the absolute minimum. I'm going to teach you the trick to doing this faster. So raise your thumbs up or thumbs down if you recognize this is the absolute minimum. Thumbs up or thumbs down so I see. Okay, good. Now here's the shortcut. Are you ready? We are going to go second, calculate minimum, and I don't want you to do anything more. Just second, calculate minimum. Now this is in right now, this is in the x's. It was in the standard window for x's. So it goes all the way to -10 and all the way to +10 right now. So in this window, I want to choose any x value that's over here. It needs to be left of this minimum. So let's try, I don't know, let's try -8. And as long as this temporary line is to the left of this minimum, I'm good. That means somebody could have chose -7, -6, they'd have been good, -10. Now I want to choose a value that's to the right of this. So let's try -1. And once you have these temporary walls that are to the left and to the right of our minimum, we just press enter, and there is the coordinates of the absolute minimum of this graph. 2 more we're going to do. Please turn to your partner using your pencil, pen, or finger. I want you to identify on the graph with your finger or a pencil or pen, where is the relative, also known as local maximum? Where is the relative, also known as local maximum? Next up, where's the relative or local minimum? Where's the relative or local minimum? Okay. Now, using precision, we're going to find those points. Back up here. You ready? Second, trace, maximum. We're going to find the relative or local maximum. So, I want to choose any value to the left of this, like -2. As long as my temporary line is to the left of the maximum, we're good. And then I'm going to choose like 1. As long as my temporary line is to the right of it, I press enter, and this would be the coordinates for the relative maximum. Right, so while students are doing this, I'm going to find the relative or local minimum. Second, calculate minimum. I want to go somewhere to the left of this. Let's go 1 to the left. Somewhere to the right, let's go 5. I press enter. I end up with this coordinates. Can I have a thumbs up or thumbs down in class if you were able to come up with that? Please do second plus 712. For this video, we're on our final example. And what I need you to recognize is that when you have a numerator and a denominator, you must include parentheses, even if it doesn't show on your paper as you plug it in. So let's go up to y equals, and we're going to type in x plus 4 in parentheses, divided by x subtract 1 in parentheses. Now I'm going to hit zoom standard. Looks good. You have 10 seconds using one of 2 different methods that I told you on a calculator to identify what is the y coordinate that corresponds with -3. Go. Thumbs up if you have a -0.25. Thumbs up. Help your partner if they don't. Now this is where it's tricky. I want you to find the y coordinate that corresponds to 1. How many of you have just a blank? Okay, we're going to learn about why is this. It's because there's a vertical asymptote. That's what we're going to learn about later on this semester. When you see no number here, don't put a 0, because the 0 would be associated with actual value. We're going to come up here and just put a line, or you'd say none. All right, this is going to lead into our next lesson, but let's find the x-intercept. So the x-intercept when y equals 0. Let's come back here. Here is my x-intercept. Another term for x-intercepts are zeros. And so I'm going to teach you the fast method. Can everybody hit second, calculate 0. Second, calculate 0. So left bound, I want to choose any number that's to the left of this. Any number that's to the left. So I'm going to choose like -7. Good. The line that's temporary is to the left of where I see the x-intercept, also known as the 0. Now it tells me to make a line that's to the right, so I'm going to choose -1. Again, you could have chosen different arbitrary numbers as long as they land to the left and the right of the x-intercept. Now I press enter, and there is my x-intercept. Help your partner get that, because that's challenging. Help your partner. Finding the y-intercept is much easier. To find the y-intercept, we're going to go second, calculate, value, and for y-intercepts, x is always 0. Our y-intercept is 0, -4.